guys, today we are going to have some fun working with word problems. So we are going to be talking about different things and using models to help us solve word problems. A model could be a number line, a bar model, it could be a picture, whatever you need to be able to solve the problem. So today our I can statement, I can solve word problems using a model. Let's get started. All right, guys, get your math notebook out so that you can get the lines drawn in there and we can get started on our concept board. Number 1, this is again going to sound a little familiar, but we've changed the numbers and it's gotten bigger. There were 3 kids standing in a line. Some more kids joined the line. Now there are 12 kids in the line. How many kids joined the line? So there's 3 kids. There's some more that come, but we don't know how many. Then there's 12 kids in line. How many kids came and joined the line? Number 2, draw a shape with 4 equal sides, and 4 vertices. Remember, equal sides means they have the same length. Then, what equals 1 plus 1? Make sure you write your number sentences when you solve them. What equals 2 plus 2? And what equals 3 plus 3? Our number sentences can be written this way. So whatever the answer to this is, you're going to write it in the box. Write down those number sentences. Then skip count by tens to 120. So you're going to count by tens all the way up to 120. Skipping some of the numbers in the middle, only counting by tens. Make sure to pause the video and answer these questions in your math notebook. All right, so to solve number 1, I knew that I started with 3 kids in the line. So I drew 3 kids in blue because that's the color I chose. I knew that we started with 3 kids, so I have those on there. Then some kids joined the line. I don't know how many kids that was, but I do know that once everyone was in line, there were 12 kids. So what I did was I took my red color and I added units of 1 to my bar model until I hit 12 kids in the line because I knew that 12 was the most kids that I could have in the line. Then I knew that any of my red units of 1 would be how many kids joined the line. So when I counted them, I found that there were 9 red units of 1. So my 3 original kids in the line, my 3 kids in the line, plus 9 more kids that joined the line, which was the number I found, equals 12. So that is what I did to solve number 1. Number 2, I had to find a shape with 4 equal sides and 4 vertices. So you could have either drawn a square which has 4 equal sides and 4 vertices, or a rhombus, which is like a square but it's tilted. So you could draw that. It has 4 equal sides and 4 vertices or corners. Good. Now we have 2 equals 1 plus 1. So when I did that, I found it was 2. 4 equals 2 plus 2. That's my double for that. And 6 equals 3 plus 3. Good job. Last, I skip counted by tens. I did this and wrote it out. You also need to make sure it's written out. These little dashes are called commas. They're just separating my numbers to make it easier to see. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 110, 120. Nice job, guys. Please turn in a picture of your completed concept board in Seesaw. All right, we are going to start with this word problem. I'm going to read it. There are 11 birds in the tree. 5 more birds come to the tree. How many birds are in the tree? So we need to try to picture in our brain what's happening here. So I'm going to picture a tree in my brain. And there are going to be 11 birds on it. Then it says 5 more birds come to the tree. Does that mean they're getting closer to the tree or further away? It means they're getting closer. They're coming into the tree. So I'm going to think my tree with 11 birds. Now there's going to be 5 more birds coming into the tree. So there's going to be 5 more birds on there. How many birds are in the tree? So we have to figure that out. Now, we could use lots and lots of different strategies to solve this. I'm going to use a number line because that's what we've been working on. So let's try and find our important numbers. We have 11 birds in the tree to start. Then 5 more birds come to the tree. They're coming in there. But it doesn't tell me how many birds are now in the tree. So I'm going to have 11 birds plus, because there's more that come to the tree, plus 5, because that's how many it said. And then I don't know how many birds there are altogether. So we're going to make a number line to help us solve. Remember, a number line needs a nice straight line. So I'm going to start at what number? 11. I could start at 0 if I wanted to, but then I would have to make 11 jumps before I even start my problem, and that would take quite a bit of time. Then we have 5. If you know how to decompose 5 into smaller numbers and you want to make jumps of 2 or 3, you can. Or you can do what Mrs. Mead is going to do and make jumps of 1. So I really make sure that I'm keeping track of how far I've gone. So from 11, I need to go 5 jumps of units of 1. So 11 plus 1 would be 12. I am now at 12, but I've only jumped 1 time. And I need to jump how many times? 5. Good job. So I better keep going, making sure to iterate my jumps to be the same size. 12 plus 1 is 13. I could also say 11 and 2 more is 13. 2 jumps is not enough. I better keep going. So 13 plus 1 more is 14. Very nice. How many jumps have I gone? 1, 2, 3. I've only gone 3 jumps, which is not the same as 5, so we better keep going. Another jump of a unit of 1. Plus 1. 11 and 4 more is 15. If I don't know the answer to that question, I can also say 14 plus 1 is 15. Good job. Now I've gone 4 jumps. Is that the same as 5? Nope. Better keep going. Another jump of plus 1. Trying to iterate the size of my jumps to be the same size. 15 plus 1 is 16. How many jumps have I gone? 1, 2, 3, 4, 5. I've gone 5 jumps. Is that how many I needed to go? Yes. So, as long as I've done everything correctly, if I look down at the last number of the last jump, it should match the number that I need for my answer, which is 16. Good job. Remember, you can always check your counting sequence, and you should, to double check that you haven't skipped any numbers or missed a number. Let's check that real fast. 11, 12, 13, 14, 15, 16. Great job, guys. So, now we're going to come back here. How many birds are in the tree? We want to say in full sentence, there were 16 birds in the tree. So I can write 16 birds so that it's got a nice, pretty label on it. Great job, guys. All right, here's our next problem. I shall read it to you. Follow along as I read. There are 12 birds in a tree. Some more birds land in the tree. There are now 19 birds in the tree. How many birds landed? Now, is this problem saying that I have 12 birds and then some more birds come, but it's not telling me how many birds, and now I have 19 birds in the tree? Or is it saying I have 12 birds in the tree, now there are 19 more birds, so there's a huge number of birds in the tree? It's the first one. It's telling me there are 12 birds, so I'm picturing 12 birds in a tree. Then I have some more birds coming, but I'm not going to know how many they are because it's not telling me. Now that all the birds are there, there's 19 birds total in the tree. And it needs us to figure out how many birds were added to the tree. So my problem would be 12 plus something, however many birds landed, equals 19. That's what I'm trying to figure out. So I'm going to use a bar model to help me solve this one. I'm going to start by getting my 12 birds on the board. All right, I have my 12 birds that were originally in my tree. These were the 12 birds in a tree right here. Now, I have some birds coming into the tree, but I have no idea how many that is. That's why we left it blank. But how many birds will there be all together when I'm done? 19. So I need to add units of 1 to my bar model until I have 19. Are you ready? We have to try to make sure we are iterating our units of 1 to be the same size. So there's a unit of 1. I'm at 13 now. Now I'm going to add another one because that's not 19. Now I'm at 14, trying really hard to keep my units of 1 the same size. 14's not 19. Better add another one. 15. Is that the same as 19? Nope. Gotta keep going. Add another one. Now I have 16. That's not 19, so I better add another unit of 1. Now I'm at 17. 17's not the same as 19. Better add another one. Now I'm at 18. Is 18 the same as 19? Nope, but I do know it's close. Let me add another unit of 1. 19. Oh, that's what I needed. That was my magic number to tell me that's where I need to stop. Now, since Mrs. Me used 2 colors, she used purpley red for her 12 original birds and her blue for her birds that landed, I can now count the blue blocks so that I know how many I needed. But if you don't have the colors, you could always mark your 12 original birds, and anything above where your 12 was would be your ones that landed. So let's count how many that is. 1, 2, 3, 4, 5, 6, 7. It is 7 birds. So let's mark that so we don't forget. 7 birds. So would my answer be 19 in my blank? No, because I wasn't looking for the total. I was looking for what other number I needed to get to 19. So my answer is 7. That is what I'm going to write in my blank. So 12 plus 7 equals 19. So I had 7 birds landed. So I will write right here, 7 birds landed. So I have a nice label. Good job, guys. Hi, guys. You're going to need your blue investigations book. You are going to open it to page 229. You're going to do the 2 word problems on this page. Do the best you can. Use a model. You have to use a model. You can use a bar model or a number line, or you could draw a picture, but I would really encourage you to use either the bar model or number line before doing a picture. And so solve the one about the squirrel and the one about the soccer ball. Do your best, use your model, and try to write that number sentence to match your model. That will be so helpful. And just do your best. Try and follow what the word problem is asking you to do. Ask for help if you need it. and submit a picture of this and your concept board into Seesaw when you're done. Have a great day, guys.